In current affairs related to astrophysics and especially outer space, this concept of black hole, singularity, gravitational lensing, gravitational waves has always been in use, and UPSC has been asking questions on this topic. In order to appreciate the nuances behind the topic, it is important to understand the life cycle of a star. So in this video, we'll be understanding that basics and see how we can apply that to the UPSC prelims level questions. I have designed this video keeping in view the demand of UPSC CSC examination. This is not meant for IIT, JEE or other competitive examinations. While we started our geography basics, we must have read that Big Bang is the first point 13.6 billion years ago from where our universe came into existence. After that Big Bang, all that was there was dust and gas. But some particles were heavy. Due to their own weight or due to their own gravity, they started fusing together. And this fusion actually is between hydrogen atoms. Now, when hydrogen atoms fuse together due to nuclear fusion process, it releases some energy and then creates helium. So on and so forth. This process occurs till a few millions or sometimes even billions of years. Now what happens? We know that every particle, when it is spiraling around itself, there is some gravity force upon it. So this star, when it is fused together, there will be this force of gravity and everything will be moving towards the center. But at the same time, the fuel that is causing the star to shine, that is hydrogen, due to the process of fusion, will also push back that gravity because of the energy released from the nuclear fusion process. So this is the process, the first step that you have to understand. The shining of the stars is because of this nuclear fusion process, and they keep on expanding and keep on shining, or they will counter this gravity force. But what happens after that? So after a few million years, hydrogen will exhaust. So what happens later is that this nuclear fusion stops. So the force of gravity will cause the star to collapse into itself. This is the next stage. But is this the end of the life cycle of star? Not really. It so happens that because of this pressure exerted by gravity and the presence of this next fuel, helium atoms will start fusing themselves and create the next elements of periodic table that you see in our periodic table. And this process goes on till there is no more fuel left within that star. Is this the usual process for all the stars? Not exactly. Let us have a look. Let us take the example of our sun. Imagine if sun ran out of hydrogen fuel and then helium was formed. Then what happens is this helium will fuse together and this outer layers will start expanding. As a result, it turns into a red giant and even beats the influence of this gravity. In this process, even planets like Earth can be consumed. This is the beginning of the death of our star, that is sun. So after a few million years ago, what happens is this outer layer will slowly start disintegrating into planetary nebula because there is no fuel left around. And what ultimately happens is this nebula will be disintegrated from the star, and what remains is a hot mass called white dwarf. Upon cooling for a few more million years, it will eventually end up as a black dwarf. This is the end stage of a star. Mind you, we are only talking about the size of the star, which is equal to that of a sun, or maybe you can say that this is the life cycle of our sun. Red giant, planetary nebula, white dwarf and black dwarf. Just remember the stages. Now, is it justified to say that all the stars will follow the same pattern? Not exactly. What if the mass of the star that we are discussing is more than that of the sun? They follow a different pattern. So obviously, if the stars are bigger, heavier elements will fuse together. That is how the elements like silicon, carbon, oxygen, etc. came into existence in our universe. Now, after that, what happens is, just like how the red giant was formed in the case of our star, in the case of bigger stars, supergiants will form, and they will further disintegrate as a planetary nebula in the case of our sun. But what happens in the case of bigger stars is they give rise to a massive explosion called the supernova, where everything explodes into a gas because of not being able to contain that energy. Eventually, what remains is just a bunch of neutrons called neutron star. Recently, a neutron star called magnetar was in news, and therefore we have to understand this term. So you have to know that if there is a statement given in UPSC prelims that magnetar is actually smaller than sun, it is a false statement. If it is given that it is bigger than sun, it is a right statement. Why? Because it is not ending up as a black dwarf or a white dwarf, but it is ending up as a neutron star. Now, if it is even bigger than this star which forms a neutron star, all the stages will be common. Finally, because the gravity force is so huge, it will all collapse into a single point called black hole or singularity. So singularity is nothing but a massive black hole. So this whole sequence is generally called as the main sequence in the life cycle of a star. As we have already seen, I am summing up it again. If it is a sun, this is the cycle followed, and if it is bigger than the sun, this is the cycle followed. So usually you have to note that black holes are found at the center of a galaxy. So this is an important point to understand the next concept. In order to understand the concept of gravitational waves, you have to see that this is how you have to imagine. Let's say our entire universe is like a piece of cloth on which the star is dropped. Since the mass of sun is not as heavy as those bigger stars, this is how it looks. For neutron star and black hole, this is the visual representation of the concept that we discussed. Now we'll move on to the next concept. Here we have to understand the concept of blue straggler stars. Now we have seen the usual life cycle of a star. It has already huge force upon it in the form of gravity, and in order to overcome this gravity, it has to burn with more amount of fuel to sustain that pressure. Therefore, generally when we are talking about the center of galaxy, it means that it is the starting point or the point where the core of the star is there. So usually you find black holes there because of the fact that they have exhausted their energy, and gravity is actually playing a bigger role there. Now, scientists have found an anomaly. At the center of galaxy, they found young bright stars which were burning with very high luminosity or high light, and they named them as blue straggler stars. So it remained a puzzle for the scientist as to how at the center of galaxy you can find such bright stars, because usually, like we have discussed, that is the place where you will find black holes. There will be no light at the center of galaxy in most of the cases. To explain this further, let us have a look at this. Say for example, there is one star which is having some 10 times the mass of that of the sun, and there is another star which has a mass of 100 times that of the sun. So usually this will be under even more higher gravitational force, and the fuel that this star must use will be much faster than the smaller star because it has to survive. So the rate at which this burns out is faster. So bigger the star, the less is the lifetime. So usually they end up as black holes, but in the case of blue stragglers, it is right now speculated that two big stars are fusing together and adding their combined energy to burn brighter. That is how you see blue stars. The reason exactly might not be asked in the examination because we are still not yet clear. The puzzle is still remaining, as you can see in this article. So this is the speculation. You just have to know the term blue straggler and how it is an anomaly. That's all will be asked. So this is the life cycle of the star, and I hope you found this useful. That's it for now. Thank you.